Now, another mode of determining the volume of a solid, and this time where the solid is hollowed out, is the method of washers. Now, in the case of the method of disks, okay, I said to think along the lines of circular area. And now for the method of washers, you can think of the difference between circular areas. So we can have the difference between the area of the outside circle and the area of the inside circle. And we can say that with the method of washers, and we say that for functions f of x and g of x, between x is equal to a and x is equal to b, we can say that the volume of the solid generated about the x-axis. And let me give you just a bit of a preview here. Okay, we say that for f of x, we call this solid section. And for that which represents g of x in the general case, we can just call this the hollowed out portion or section. Now, in the case of the volume of the solid generated about the x-axis, so we can say that v of x is equal to the integral as x goes from a to b. And we say we have pi times the quantity, where we have the quantity of f of x squared minus the quantity of g of x squared dx. And let's say that in the case of the method of washers, so you had the determination of the volume of the solid about the x-axis given. And we'll say that we have y is equal to f of x is equal to 4. And we have, for the other function, we say we have y is equal to g of x is equal to x squared between x is equal to 0 and x is equal to 2. So if we take what we have here in the setup, so again, if I insert some graphs, okay, so again, we have with y is equal to 4. Okay, so we're going to have a horizontal line, so we have the y is equal to 4, and we have for y is equal to x squared, and again, we're looking at generating this item about the x-axis. Now, in looking at what we have here, okay, so we have above, we have y or f of x equal to 4, and we have also y is equal to g of x is equal to x squared. And if I'm looking at revolution about the x-axis, now again, you have x squared is going to hollow out what would otherwise be a right circular cylinder with a radius of 4. Now, in the case of what we have for the solid, okay, so you have generating about the x-axis. Okay, so think of this as being like one disk inside of another. Okay, so we have for the outer disk, this will be in correspondence to y is equal to 4. And then we have, in the case of the inside, so we have for the outer radius, we have, again, corresponding to the height in the 2 dimensions. Okay, we have outer radius is equal to 4. And as for what we have, essentially for, you can regard this as a bit of a donut hole. So you have the inside radius, okay, is going to be equal to x squared. Okay, and now in terms of our contact points, okay, again, so we have between y is equal to x squared and y is equal to 4. We have for this 3-sided shape, okay, so we have the origin 0, 4, and also where the graphs intersect, we have at 2, 4. So we'll be looking at integrating with respect to the variable x. So for the volume of the solid generated about the x-axis, so here we're going from x is equal to 0 to x is equal to 2. And we're going to have, I could distribute pi, but I'm just going to go ahead and leave this on the outside. So we'll be looking at pi times what is going to be the difference between the outside and inside functions. Okay, now the outside, okay, we have represented by 4. So you have pi times the square of 4. And you have minus the square of the inside. And then looking at what we have for the distribution. Okay, so we have pi over 4 squared. Okay, so we can say we have 16 pi minus pi and x to the second squared. That's going to be x to the fourth. And then looking at, okay, what we have for the attainment of the volume. So we have for v of x. Now we have for the antiderivatives, we have 16 pi x minus pi times x to the fifth over 5 as x goes from 0 to 2. And in the case of what we have for the exact result in this particular case, now we're going to arrive at 32 pi. 2 to the fifth is 32 divided by 5 multiplied by pi, so we have minus 32 fifths of pi. And so for the volume of the solid generated about the x-axis. So this will end up at 1/28 fifths of pi. Now, let's say that if we're looking at, say, a situation whereupon we can say that we have it as another situation that involves the use of the method of washers.